Today I'm talking about seamless database management for Cloud Foundry and Kubernetes. Um, my name is Julian Fischer, running a company called Anynines. We are running Cloud Foundries for a living, and data service automation is our second passion. So today we are talking about, in particular, an open source technology that we've released that is called Klutch, like the clutch in a car, so to say, bringing together two moving parts effectively. Um, the entire idea of Klutch is basically that in a time where most organizations have to adapt Kubernetes in some way, without the having one platform in the center of it all, some of the challenges arise on how to, data service management is one of them, how to do data service management in a meaningful way in a world where there's a Cloud Foundry and there are many Kubernetes clusters at the same time. So the scope of customers we are talking about in this context is that you can't know which infrastructure you are on. You could be on Amazon, you could be on Azure, you could be in on-premise scenarios. There are hundreds of Kubernetes clusters, at least dozens of them. There is a Cloud Foundry, obviously. You want to have certain amount of centralized control. You want to have the operational efficiencies you're used to from Cloud Foundry. You want to get into the swamp of having hundreds of Kubernetes clusters that are somehow self-managed by the application developer teams and scatter data wildly across the place. So streamlining database management, similar to what you know from Cloud Foundry, is one of the objectives. And then also have the freedom to choose from automation backends, whether it's getting an Amazon DynamoDB or an anynines Postgres or any other Postgres operator you choose from the greater ecosystem should be able to integrate. And also you want to have the on-demand developer self-service. So the motivation of this is that if you're using Cloud Foundry for a while, you know that, well, you got the service broker API, the open service broker API, and you got some sort of data service automation that you plug into your Cloud Foundry, and your application developers are happy. If you think about how streamlined that user experience is in Cloud Foundry, you will see that in the Kubernetes ecosystem, there isn't anything alike. So you're not replacing a Cloud Foundry. Most of the attempts to replace it, I've seen customers abandon it because it's just Cloud Foundry delivers something that cannot be easily imitated in Kubernetes. And any Kubernetes strategy that I've seen in large organizations, and you end up with a lot of Kubernetes clusters. So in our case, this looks similar, familiar. In our stack, we have the anynines data services, we have our service broker. So it's just a typical thing you do on Cloud Foundry. And this works fine if Cloud Foundry is all you need. However, if you adapt Kubernetes, then you're looking into a lot of different Kubernetes clusters owned by individual application teams, and that's when the headache starts, because your platform fragments quite a lot, and that creates overhead. And in particular, Cloud Foundry came with, let's say, we always called it the data service challenge or cloud service challenge. So you have to have a set of service brokers that do the job well. Now, in the Kubernetes ecosystem, this is even worse because you have operators. But do you really want to, have your database instances owned by application developers? And for small environments with highly skilled teams, this is actually feasible. You can't do that. You can't pull it off. But if your organization is large and you have a lot of application developers or developer teams who lack of that cross-functionality, then having local operators doesn't really scale. So the desire emerges that you want to separate application clusters from managing databases. And this is basically what Klutch does in a nutshell. So you take application clusters, you plug in a Klutch client, and this Klutch client introduces custom resource definitions for representing service instances, service bindings, and we also extended backup plans, backups, and restores, which makes it possible for application developers to declare service instances with a similar comfort than you would expect in a Cloud Foundry environment. But while having a central control plane that runs on a management cluster that basically knows all the declared states of all the service instances across all application clusters. So this is the sort of cloud controller in the system, in a system where there's, at this point, no Cloud Foundry. And also, it allows you to integrate arbitrary automation backend. So anything that manages a database can basically be integrated. So a prettier version of the picture is this, where you have a lot of Kubernetes clusters at the left, where you install the Klutch connector. You have the Klutch control plane. And as you can see, or maybe can't see from this illustration, you're using crossplane to write those automation integration backends. So you're leveraging something that's quite popular already, that has a lot of, stuff you can basically work with when you do those integrations. And all you do writing an integration is basically telling Klutch how to build a service instance using crossplane integrations. So the control plane centralizes metadata. The connector is offering the CRDs to the application developers for creating a Postgres instance, for example. And all these desired states are then replicated to the Klutch control plane and eventually reconciled with the actual automation backend. So you can use Klutch also to expose services you've created internally to the organization to a large number of Kubernetes clusters. They're all written in Go. It's native Kubernetes operators. And this is how you get the service instances off the application cluster. So the main idea here is, in a world where Cloud Foundry is not the only platform you have, you want to have something that allows you to your platform team or your security team to have a central metadata registry about where cloud service instances are and where they are being used. So Klutch introduces a control plane that resembles the functionality of the cloud controller in a fleet of Kubernetes clusters. And obviously, it works across infrastructure. So you can integrate service backends that are, well, let's say, multi-infrastructure capable, such as data service we provide, or you introduce integrations for the, let's say, Amazon RDS or any other service you would like to consume and expose to your application developers. The application developer perspective, and I will get to a Cloud Foundry part. This is not about Kubernetes alone. So the Klutch abstractions are done in a way that it inherits from the Open Service Broker API conceptually. So it elevates them into Kubernetes native abstractions. So we still have service plans, service instances, service bindings, and we've added backup plans to declare when a backup should be created regularly, like a cron job for creating backups, and also restore operations to restore backup, obviously. So this is an example how you create a Postgres instance. And as you can see, very in the lower part of it, it's using a backend called AWS Postgres. That's an operator that creates Kubernetes pods. You can change the declaration like this, and you're now using anynines Postgres, which is creating BOSH managed VMs. So you can see swapping the automation backend for Postgres is pretty simple, and for the application developer, mostly transparent. You could also swap out, create a MongoDB instance like that. So it's pretty similar with Cloud Foundry, that you make the creation of a database instance very simple. We're currently building integrations for Amazon RDS as well. And if you think about creating an RDS straight from Crossplane, you have to create an IAM user, you have to create a policy, and there are a lot of things you can do wrong. And there are a lot of things you have to know about the Amazon API to get this ready. So it's not really simple, and it's not really something that you want to give to an application developer. So Klutch introduces the open service broker inherited abstractions for the purpose of making the application developer experience simple. So service bindings, same purpose. It creates a database user and a password, and also um, creates a local secret so that your application can just, read the secret and get to the information, pretty similar to the vcap variables you would see in a Cloud Foundry app. So Klutch in action, I will keep that short. It's basically, creating a service instance spec, applying it to the Kubernetes cluster. And what the Klutch client will do is replicate that piece of information to the Klutch control plane, which will then reconcile it with the cross-plane integration, talking to the actual backend. I'll speed that up a bit. It's just a service instance spec. And whoop, and in the end, you're waiting for this service instance or service binding to be completed. So it's nothing too exciting. It's just taking the abstraction and putting it into a more native Kubernetes interface. So now we have at this point solved the problem on how to expose data service automation to a large number of Kubernetes clusters while maintaining that central control, which is nice. But if you're still using Cloud Foundry, and our Cloud Foundry users, their Cloud Foundries, they go nowhere. They are meant to stay. They are stable. They have their fans, and they want to keep using it. So now you have Klutch. And do you really want to then integrate any data service without using Klutch so that you have the service broker being addressed directly? Because then again, you don't have the central control plane. You then again miss that central overview, so to say. So wouldn't it be nice to have the central control plane in the cloud controller for Cloud Foundry, but beyond Cloud Foundry in the Klutch control plane? There's one other aspect. We created a Postgres operator, and the question would be, how do you expose this Postgres operator in Cloud Foundry? So you have to provide a service broker as well. So with Klutch, basically, you get that more or less for free as the service broker creation. You can create a generic Klutch service broker and expose anything that has a Klutch integration directly in Cloud Foundry as well. So in Klutch and Cloud Foundry, the idea is to create that service broker. And a prototype is currently being developed. It will allow you to expose any service that has a Klutch integration in Cloud Foundry, as I said. And the user experience is pretty much what you expect from a service in Cloud Foundry. So you have this service broker is registered in Cloud Foundry. You'd be able to, call the CF marketplace here using Postgres as an example. And on the Klutch control plane, you have those entities as well. So the Klutch service broker does nothing but talk to the control plane, create a service instance there, basically imitating the behavior of a Kubernetes application cluster. Creating a service instance is also straightforward, meaning that you use the Cloud Foundry service command or the whatever you use to create that command in Cloud Foundry, YAML file, or in this case, the CLI, and declare the service instance. Well, I think the prototype still requires some custom parameters that are a bit inconvenient, but this will go away in the later implementation. So here you paste some metadata, basically picking a service plan, and then the service instance is created for you. Now, one of the things that control plane makes possible, the Klutch control plane, is that if you think about having a Postgres operator, the Cloud Foundry itself has no network connection to the Kubernetes cluster. So whenever you create your first service instance, at latest when you create the service binding, you need to establish a network connection as well. And that's similar if you have an application cluster in Kubernetes. It's not only enough to declare that the service instance is there, you also need to establish the network connection, and you need to secure the network connection as well. And with the Klutch control plane, you basically get an eventing system that makes it simple to trigger the creation of a network connection on demand. So there's an extension to Klutch called the Klutch Network Connector, which is an interface and has multiple implementations. One implementation is based on an Envoy proxy that's then deployed dynamically when you declare a service binding. So the centralization of meta information gives you also more advantages, including you have a similar central control plane where you can think about billing as well, because you have the start and stop dates of the service instances and basically can have a change of all the service instance, as you will always be notified when the desired state of a service instance or service binding is being changed. So the creation of a service instance using the service broker is, to be honest, a bit boring. I mean, it's just a standard Cloud Foundry interface. You create a service and you don't see much of what's happening behind the scenes other than the right side of the shell, which is basically impossible to read. Shows you that on the Kubernetes side, the resources reflect what you requested in the Cloud Foundry part. So at some point, the ready attribute of that service instance will change from non-ready to ready, and that's when you are able to create a service binding. In this case, it's a service key, similar to any other service broker as well. So once you've created that service key, you can also connect to the service instance using the credentials from the service instance, like this, and there you go. So in order, wrapping it up, one of the challenges we see in organizations today is if they have a Kubernetes strategy and they multiply a lot of Kubernetes clusters, they run into the issue on how to expose data services to application developers gracefully. And a lot of organizations, they fiddle around with crossplane, where automation backends are directly integrated in the application cluster, where you lose some sort of central control, and platform teams really need to go through, you have to establish strong conventions in order to keep an overview in landscapes like this. So by using the Klutch control plane and Klutch itself, you can introduce service instances and service binding abstractions that make data service management simpler. And with the Klutch Service Broker, there's now a technology that allows you to streamline data service management across multiple platform technologies as well. So we are a big fan of Cloud Foundry, and we will stay in this ecosystem as long as there will be Cloud Foundry. But we also want to make it possible that those organizations that have a Kubernetes offering have something to solve these problems, because I believe the Kubernetes ecosystem started to evolve from a more decentral approach. A lot of people don't have the experience on what it means to have something like Cloud Foundry. They don't know what the degree of operational efficiency is possible. I mean, we have 10 ops and we operate more than 40,000 VMs across all infrastructures. I mean, I haven't seen many Kubernetes people doing the same thing. So I think it's our duty to help people to learn from the lessons we have learned, the hard way in the Cloud Foundry ecosystem. And, Klutch is a big contribution for a small company like us. There have been, a lot of hard blood and tears and sweat, or whatever the idiom here is, invested into this. So please feel free to try it out and give it a star on GitHub if you like it. So in the end, you want to have the same developer experience across platforms. We also look into releasing our Core fee-based product later this year. So, I mean, then you have a Cloud Foundry on Kubernetes, and you have to revisit this problem again. And Klutch will solve not only the service broker will be there for you, but also the network connector will help you to, establish the connectivity from the data service backends to your application cluster or to your Cloud Foundries dynamically. So the framework itself is fully functional. It's been developed. It's version 1.0. We do have some things upcoming like multi-tenancy and UAA that's independent from Cloud Foundry, but does integrate with it. The network connector is their first version and it works, and we are still working on the service broker and, of course, many backends. So feel free to join us. We'll be happy to share the work and see that this is becoming more popular and mature over time. So now it's your turn. I would say touch the Klutch, but I'm not sure. That sounds so nice. So let's say get in touch with Klutch and just try it out. Give it a star on GitHub. If you want to see it in action, reach out to us. We will give demos and free POC on your infrastructure, helping you to install it and just try it out. As I said, it's open source under Apache 2, and we are not going to SSPL the shit out of it. So it's open source and it will always remain so. So thank you very much for your attention and